Welcome back to Microeconomics. I'm Keith Yakucha. In this video, we're going to continue with firms and their customers, and we're going to focus in on taking a look at cost curves. This really is the second set, or potentially third. After the first one, you could go either direction into whether you go to cost curves or go deeper into the demand and the revenue side. But this is a second video in this series of firms and their customers. And in this one, we're going to go deeper into the cost side, the cost function, the cost curves of the firm and their whole decision-making process around costs. If you haven't already watched the first video, in the first video, we went through and defined profit maximization. We then went through and built up, based off of content earlier in the semester, a demand curve, which was our feasibility set. That demand curve was just built through income and substitution effects to find the ratio that we trade off between prices and quantities for a given good or service as that price fluctuates. We then went and took our profit function to determine an iso profit, that is a same profit for different combinations of P and Q. We brought these two together to say, hey, if we want to get to the highest level of profit we can, how do we maximize our profit given our constraint of the feasibility set? That is, given the constraint of the demand curve, what people are actually willing to pay for a good or service. Bringing those two together, we identified some optimal, some profit maximizing P and Q. This video carries on from there, just going deeper into the cost side. So let's go jump over, take a look at our Blackboard. To start us off, we have a bunch of that information from the previous video, and we can quickly look at that and then carry on. So here we go. As said, zoomed out view of a lot of what we had previously covered. And we have our feasibility set, our demand curve, various ISO profits, giving us our MRS equals MRT, the highest possible level of profit that could be obtained given this feasibility set, our demand curve, what people were actually willing to pay for a cup of coffee. What we're going to go into is more detail into this cost side, and going into more detail with this cost side is going to pull forward a lot of our concepts from before on things like diminishing average and marginal products of labor, both terms covered in that last video. So let's go zoom in. Let's take a look at that. Okay, so we had all together that profit was equal to our total revenues minus our total costs. Let's go dive deeper into these total costs. What we can take a look at is say that our total costs are altogether equal to our total fixed costs plus our total variable costs. The way we can think about this is that our fixed costs, these are our capital costs, our costs of the equipment, machinery, and the like. While our total variable cost, this is our labor cost, our cost of our workers, the cost of these intermediate inputs that change for every cup of coffee that we make, to carry on with the coffee shop example. The capital cost in that case there, well, this would be the cost of your lease, the cost of your coffee pots, the cost of your espresso machine, on and on and on and on. That is, these costs don't change depending on the number of cups of coffee you make. You go and make 1 cup of coffee, and you have your total fixed costs of 1,000. Maybe that's your lease and your loan for a bunch of your espresso machines and all the rest. You can make 100 cups of coffee, and still your fixed costs are 1,000. Importantly, you can make 0 cups of coffee, and still you have to pay the cost of all that capital, which is 1,000. To compare that, however, our total variable cost, well, this is just dependent entirely on the number of cups of coffee that you make. If you're making 0 cups of coffee, well, then you don't need any people to be making those cups of coffee. You don't need to be using beans. You don't need to be using cream. You don't need any of that stuff. So your total variable cost is going to be 0. However, as you start to increase the amount of cups of coffee you make, that is going to start to increase your total variable costs because every cup of coffee you make is going to require some number of workers who you have to pay a wage to. It's going to require some amount of coffee beans, some amount of the cost of the cup itself, the cost of the cream, all of those different components thereof. So, although as you increase your quantity in terms of total fixed cost, your fixed cost stays the same. For our variable costs, as you increase your quantities, you're also increasing your costs. And so we need to keep that in mind. Ultimately, though, we're not too interested in the total costs altogether. What we often want to go and take a look at is our average costs. And that is our unit cost, our cost per unit. And so our average total cost, this is just our total cost per unit, and that is going to be equal to our average fixed cost plus our average variable cost, which would just be the same thing as saying our total fixed cost per unit plus our total variable cost per unit. And what's happening here? Well, to start off, let's take a look at total fixed cost. Total fixed costs are, well, as we've said, fixed. So let's just use the numbers we had up here, 1,000. So if we had total fixed costs of 1,000, when we had quantity of 1, our average fixed cost was $1,000, right? We had our total fixed of 1,000 divided by quantity of 1. There we go. However, what happens is we increase our quantities. As we increase our quantities, we are now getting our total fixed cost of 1,000 divided by bigger quantities. Our average fixed cost drops down to $10 per unit. Go and increase this to, say, 10,000 units, 10,000 cups of coffee being sold, and our average fixed cost, that is our fixed cost per unit, is now dropping down to 10 cents. So what we see with this is that as our quantities grow, our fixed cost per unit is getting smaller, 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 smaller. Our average fixed cost we would expect to approach zero, but never actually reach zero at all. And if we were to take a look at that on a graph, this is just going to be a temporary graph because nothing is exciting with our fixed cost. It's just going to be so we can quickly see it. We have dollars, so our costs on the vertical. We have our quantity on the horizontal. We started off at a quantity of 1 at $1,000 for our average fixed cost. As we increased our quantities, our average fixed cost went from 1,000 to 10 to 0.1. We get an average fixed cost that drops and is going to get smaller, 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 smaller. It will approach this horizontal axis, but it will never ever touch it because you can never divide by a non-zero number and get zero. So average fixed cost will become infinitesimally small as quantities increase, but it will never ever become zero. So nothing too exciting, just showing that our capital cost, our fixed cost per unit, is shrinking as we produce more and more and more units. The more interesting one is going to be this total variable cost. Sorry, not the total variable cost, what I just circled, which is the average variable cost. And let's take a look at how that guy looks and how this guy performs. And I'm just going to get rid of this average fixed one because, like I said, there's nothing really interesting happening here. So again, we're going to look at the same axes. We have our vertical axes, which are in terms of dollars. We have our horizontal axes, which is in terms of units, so cups of coffee. What we'd expect, let's use green for this. What we would expect is that our average variable cost starts off at that total variable cost, right? It's just total variable cost divided by Q. So total variable cost, whatever that was, divided by 1 is just total variable cost. And then we would expect that initially our total variable cost is dropping, would hit a maximum, and then would start to climb. And that would be our average variable cost. That is, again, what is our unit cost per our cost per unit. I can't say unit cost per unit, that makes no sense, but that's what I was trying to say. This is our cost per unit, and we witness that initially as we produce more and more and more things, well, our variable cost per unit is shrinking, 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 hits a minimum, and then begins to rise altogether. If we were to also throw in here that, let's use gray because it's not really all that important. There's no relationship as to where these curves actually fall. Let's say that's our average fixed cost. Well, what you can see is that our average total is just average fixed plus average variable. So taking a look at when Q was 1, we had an average fixed of 1,000. We have an average variable of whatever that is, something bigger than 1,000 apparently. So we get that one plus that one, and that gives us, let's go to blue, that would give us our average total cost, which is just average fixed plus average variable. What's going to be the shape of that average total cost? And you might be like, whoa, Keith, you haven't even explained why the average variable cost is the shape that it is yet. Don't worry, we'll back up, we'll get there. We just want to take a look at this relationship first. What's happening? Well, initially, all the curves are falling. So initially, average total cost is falling. We then see, well, okay, right here, as we reach this quantity, average fixed cost continues to fall, but average variable cost is starting to rise. What's going to happen is initially average variable cost isn't rising very quickly. So the average fixed cost wins out and average total is going to continue to fall. But then average fixed is getting smaller, 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 smaller. Average variable is starting to significantly rise. So then our average total hits that minimum. And then our average total is going to start to rise and is again going to be U-shaped. It will start to get infinitesimally close to the average variable, but will never, ever, ever touch it. And again, the reason why it will never, ever touch it is because the distance between average variable and average total is the value of the average fixed. And so initially, there's a big distance between the two because initially our average fixed cost is large. As we increase our quantities, the fixed cost per unit is getting smaller, 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 smaller. And so as we increase our quantities, the distance between total and variable cost gets smaller, 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 smaller. And so we get our 3 different average cost curves. Although, as I was saying, the average fixed, drew it in gray because I said, hey, it's not that important. We often don't even bother to portray this one because we can always back it out as the vertical distance between the average total and the average variable. So not of huge interest to us, not something we often actually portray. Okay, well, let's back up and we're going to get to this average variable cost curve. What I want to do just before that, so we can kind of hit 2 birds with 1 stone, really just breadcrumbing you along here, is taking a look at one other aspect of our cost side, and that's going to be our marginal costs. So scrolling down to make some room, we can take a look at our marginal cost, and this is just going to say, hey, what is our extra cost for an extra unit produced? And if we go and work through that, well, our total cost is, so change in total cost, that's going to be the change in our total fixed plus our total variable all over the change in quantity. Well, hey, total fixed cost is fixed, so it does not change. So really, this is just going to simplify down to being the change in our total variable cost for a change in quantity. And really what we're getting at each point is just, hey, what's the extra cost to produce an extra unit? If I were to make an extra cup of coffee, how much do my costs go up by? And what we typically expect to witness for the shape of this marginal cost curve, and again, just take me at face value right now. We'll go in, we'll explain all of these shapes in just a second. Marginal cost is going to dip, start off, dip, comes up through that minimum average variable, that minimum average total, and then just carries on upwards. There we go. So importantly, it hits that minimum average variable, that minimum average total, and then just carries on from there. Marginal cost relationship with average fixed cost, nada. Again, we typically don't even draw that average fixed cost. It's just there is a residual right now. Okay, what is happening? Why do these have the shapes that they have? What is even going on with this? Well, let's back up. Finally, after breadcrumbing you for a bit, let's go and explain this. And to explain this, you need to bear with me through a little bit of algebra. Okay, marginal cost, change in total variable cost over change in quantity. Similarly, if we go and take a look at our average variable cost, we said average variable cost was just the total variable cost over a change in quantity. Let's make a simplifying assumption here. And this is very grossly simplifying, but let's presume instead of being our coffee shop, we're just strictly a services-based industry. So all we're doing is we're just having labor costs, and all we have is the wage that we pay our workers. Maybe we're a consulting firm, for example. Okay, well, if we are a consulting firm, our total variable cost is just equal to the wage times the amount of workers that we have in order to produce that amount of units, that quantity. If we want to make more units, well, we need more people. Oh, look at that. As we want to make more stuff, we need more people. What are we getting at here? We're getting at our production function, the relationship between farmers and output, the relationship between the amount of workers we have and the amount of output, such that we get this diminishing average product of labor. Wait, how did we write average product of labor? We wrote average product of labor. That's sloppy. Let's try that again. Average product of labor was what is our output per worker. What do we have here for this average variable cost? Well, we have wage times workers per unit of output. So we're paying each of these workers some fixed wage, but we're adding more and more and more and more workers, but getting less and less and less extra output per worker. Keep in mind, we introduced in that last video, let's just quickly remind ourselves of this. We called this our product curves. We said we had output per worker. We were then taking a look at our number of workers, and we said, hey, our average product of labor curve looked something like this. Average product of labor. Oh, this is neat. Our average variable cost is just the wage times the inverse L over Q. Our average product of labor is just output per worker. Our average product of labor curve looks, I don't know, like a little hill, where the resulting impact is that our average variable cost curve looks like a U, an inverted hill. And that is initially our variable costs are falling as we increase our quantity because initially our average product is increasing. We're adding those initial workers who can go and they have a coffee machine waiting for them to use. They have an espresso machine waiting for them to use. But then we hit that point where that's no longer the case. We hit that point where average product of labor is maximized, and now we have the reality that we see over most of our production process, which is diminishing returns. And now you add an extra worker to your coffee shop, and they don't have a piece of capital to use, so they have to queue. They have to wait. They can help each other with breaks. They can jump in where they can, but the output per worker begins to diminish. As that output per worker begins to diminish, and we're paying each of those workers the same wage, the result is that our cost per unit begins to rise. So this average variable cost curve being U-shaped is entirely being driven, entirely being described by this whole diminishing average product of labor. Okay, but what about that red one? What about the marginal cost? Let's talk about that. So again, we have up here, marginal cost is just change in total variable cost over change in quantity. Well, again, we can open that up. What was total variable cost? Well, we said, let's presume we're just consultants. We can say that is W times L, all over change in quantity. If we presume that we need to pay all of our workers the same amount, well then W, our wage rate, is fixed. We can just take that out. We can factor it out altogether. So we get wage times the change in workers all over the change in output. And again, what is this term? Well, maybe in the last video, we took a look at this term, the marginal product of labor. That is, what was the extra output we got for adding an extra worker? And we see again, we just have this inverse relationship between the two, scaled up by our wage rate. And this marginal product of labor looks something like this. Marginal product of labor quickly goes, spikes. We hit our point of congestion right there at the top. That is, initially we're getting more output, more output, more output for every additional worker we add. We hit our peak, and then we quickly drop off such that every additional worker we add gives us less and less and less extra output for that additional worker. They always cross at the maximum average product of labor. And again, we looked at that example between average and marginal grades to explain why that must be the case. Big thing here. Well, if our marginal product of labor is just change in output for change of workers, our marginal cost, the extra cost for an extra unit being produced, is just the inverse, the change in workers for a change in output times our wage. So where this guy spikes and then drops down, our marginal cost curve initially dipped. As it dips, we hit that point of congestion there. And then as we have diminishing marginal returns, our marginal costs begin to rise. This point here, A, where it crosses the average variable cost curve, that is one and the same as this point right here, A. And the reason why this is a maximum is because beyond this, we're pulling down the average product of labor, is the exact same reason why this is a minimum. Because beyond here, as we had more and more and more Q, our costs are rising faster than the average, so they're pulling up the average cost. Similar with the total. Beyond that point there, the minimum average total, our extra cost per extra unit is rising faster, so those costs are pulling up the average costs. As a result, we get our cost curves all together. Big takeaways with this. Big takeaways, what do you need to know from it? Okay, big takeaways, fixed costs are decreasing, just falling off because we presume capital is fixed in the short run. We can't change our levels of capital. Average variable cost is U-shaped. The reason that our variable cost starts to rise is because we presume that we have these diminishing average products. So the diminishing average product, the fact that our output per worker falls, means that because we have to pay our workers the same thing, our costs begin to rise. Our average total costs then begin to rise, primarily because the variable costs rise. The whole thing is being driven by this marginal cost, the extra cost for an extra unit, which again is upward sloping entirely because we have this diminishing marginal product of labor, such that for every additional worker we add, we get less and less and less total output. To round off our conversation with costs, I want to touch on a few points. The first is that in this, the way that we've drawn this, these are our costs in the short run. And I want to define the short run, and that's a little bit sloppy of me to leave this till the end, but our defining feature of the short run is that our capital is fixed. We cannot, in a short run period, acquire or get rid of some amount of capital. And this is one of our defining features as to why we have, to a degree, these diminishing products of labor and diminishing marginal product of labor. Is because, hey, we have that fixed amount of capital. You're trying to use it, but you're getting congested. You're getting in each other's way. So your output is falling per worker added. If we could match if we could match worker to capital, and hey, for every extra worker we hired, we also brought in more capital for them, we could, to a degree, mitigate or offset these diminishing products. Of course, you would then run up against other constraints, such as just the planetary boundaries. So, something like the amount of land you have available to you, the technology about the amount that you could produce. If we're talking about farming, the nutrients that are in the soil, even if you perfectly match tractors to workers, you would still get eventually these diminishing products. It would just be farther out that you begin to witness it because you've overcome that capital problem, but you still run into others. So we'd still expect to see this. We can just postpone it. We can kind of flatten it, if that makes sense. So, okay, these are short run because capital is fixed. That is, we have the other side of it, which is we would also have our long run costs. And in the long run, this would be a case where we're not just having variable costs being our labor costs, but we're having the choice of both capital and labor. So that is, we can overcome a lot of that issue that I was saying around these diminishing marginal and average product by pairing capital and labor perfectly together. And we get a little bit of different shaped curves. A little bit different because we no longer have a differentiation between capital and labor costs because capital is also varied. So capital is no longer fixed. So capital and labor together being varied are just both variable costs, meaning all we have are our costs. And so we would just have instead of a average total, average variable, average fixed, we would in the long run just have a long run average total cost curve. Sometimes just a long run average cost curve is how this is referred to. So let's take a look at this and talk about the features of this long run average cost curve. Here we have pre-drawn for us our long run average cost curve. In this case here, it's long run because it includes both the capital and the labor costs. And really the way we're finding this is just our total cost per unit. So total cost per unit, and that is how we get this. What we have altogether is what we'd witness as three distinct sections. First, we would have our decreasing section, and let's see if I can showcase this, something like this perhaps. There we go. There we go. So our decreasing section up through here, what we would say we have, and let's just use the typer for this, would say that we have increasing returns to scale or decreasing average costs. And what's happening? Well, the idea is what's happening is that as we increase our quantities, well, we can now start to obtain specialized capital, specialized labor, such that the resulting cost per unit, because keep in mind that's what we're looking at, unit costs, as we increase our amount of cookies being made, our costs per unit are falling. And to give an example of this, let's suppose you're making just that. You're making cookies. To start off, you're only making 100 cookies. You're making them in your oven at home. It's just you. As a result, your cost per cookie is quite high. It doesn't make sense if you're only making these few cookies to go out and rent an industrial kitchen, to have a giant industrial oven and all the rest. However, while that may not make sense if you're only making 100 cookies, it may make sense if you increase your cookies to 1,000, 100,000 cookies. Now, although that industrial oven, that industrial kitchen may be quite expensive, when you've ramped up your production so significantly, that cost per unit allows you to produce those units far more efficiently, such that your costs per unit, your average costs, are falling. You're getting an increasing return to scaling up your business. Increasingly, what we're witnessing in the modern world, with so much of it being service-based and technology-based, we are witnessing more and more firms that are facing just these increasing returns to scale or decreasing average costs over the entirety of their feasible quantities. So the feasible set that they have available to them for quantities produced, they entirely have these decreasing costs. This potentially creates a problem for us from a view of competition because it becomes a winner-take-all market. And let's just kind of evaluate this before I move on, because it's a rather important point. Let's suppose that the entire market is right here. This is Q max. The entirety of the marketplace, everybody who would ever want to buy this good or service would only ever buy Q max. So the issue is, if we split Q max between 4 different firms, so each of them are only getting 1/4 Q max, 1/4 of Q max, well then, they are up here facing those unit costs. And so higher unit costs are going to translate into higher prices for the consumer, for you and I. However, if instead of having 4 firms competing against each other to provide Qmax, let's say instead we only had, let's just change colors here, let's say we only had 2 firms. So it helps if I use the right tool here. There we go. We only had 2 firms, so each of those 2 firms are splitting Qmax in half. Well, now what we get is lower unit cost per firm. Lower unit cost per firm means that they could, and I want to emphasize that could, pass on some of those savings in unit costs to lower prices and thus better, cheaper products for you and I, the consumer. But here's kind of the catch, is it is absolutely the cheapest if you only have 1 firm producing and selling to the entirety of the market. So whichever firm can get biggest, fastest, and supply to the entirety of the market is able to capture that entire market at the lowest possible unit cost, and lowest possible unit cost altogether, they now have 0 competition. So while they have the absolute lowest cost of production, they have now 0 incentive to actually pass along those savings to you. And so although they get the cheapest costs of production, we don't necessarily see that in the cheapest prices for the good and service for us to buy. And that can be problematic if we have entire industries that are just entirely increasing returns to scale or decreasing average costs. You just have a race to be big. It's just winner takes all markets that destroy competition. And as they destroy competition, they destroy consumer welfare. So potentially problematic. Potentially. Let's clean up. Let's keep talking about the rest of this shape of these curves. Okay, so as we're going through, we've taken a look at our increasing returns to scale, our decreasing average costs, right at this dotted line where we pivot from decreasing average costs to what we would call constant costs. We would have what we would call our minimum efficient scale, MES. At this quantity right here, that is our minimum efficient scale. That is the lowest unit cost that we could possibly have at the lowest quantity. From here on, if we were to continue, let's just block off this next stretch. This next stretch here, through this part here, well, we could call this our constant return. So it helps if I can type returns to scale, or constant average costs. Through this section, what's happening as we increase our quantities? Well, we've already had all of those gains from scale. We've already had all those gains from getting the specialized capital, the specialized labor, all of the specialization and efficiencies that could be found through growing have been found. Now all we're doing is we're just doubling. Hey, we found all those efficiencies. If we want to double our output, we just set up a second shop, doubling our inputs. So double our input, get double the output, we get a constant average cost, a constant return to scaling up our business. There's a period of time, a period of quantities where those are possible. After which time, though, we get into this last section of our long run average cost curve, and we call this last section a increasing, my apologies, I'm starting off, let's keep it consistent. I started off with returns to scale, so it is a decreasing returns to scale, or an increasing average cost. And what's happening with this? What's our story? Well, eventually, at some point, your firm becomes large enough that you need to start adding the bureaucracy into it. You have to start adding cost centers. So our original story was something like, hey, you're a baker making cookies. Initially, as you're producing more and more and more cookies, you're just hiring more and more specialized bakers. You're buying rather, more and more specialized equipment. Great. All of those costs go directly into making more cookies. So yes, you're spending money to get more workers. Yes, you're spending more money to get more capital, but those workers, that capital directly gives you more output and in a more efficient way. You then hit the point where, again, to increase quantity, all those efficiencies have been found. So you just start doubling up. But again, only doubling up on the labor, on the capital that actually gives you more cookies. Now we start hitting a point where you have such a large organization that maybe you need an accounting department. You need someone to do your taxes for you. You need bookkeepers. You need an HR department. All of these departments are necessary to manage your workforce, to manage your capital, to make sure that everything is working the best that it could. But I want to be clear, by adding the bookkeepers, by adding the HR professionals, by adding all of these other professionals, they are not making more cookies for you. They are entirely just dealing with the internal operations of your company. And so as a result of this added bureaucracy, necessary bureaucracy, but by adding this extra layer of complexity, you end up getting higher and higher and higher average costs, unit costs, because you have to add in these cost centers to begin to manage parts of your business. And so we get these three distinct parts of our long run average cost curve. Initially, we can find efficiencies. Then we found them all at our minimum efficient scale. We can then just double up on those and just expand our business at scale. And then eventually we hit some point where all we're capable of doing is, in order to produce more and more stuff, we have to add more and more cost centers to manage our internal operations, which just begins to push up our cost per unit. Again, one of the big concerns are when we have industries that are entirely decreasing average costs, entirely increasing returns to scale, and that is, these are winner-take-all industries, and they become problematic because they can destroy competition. It just encourages one large firm to rush to that maximum quantity altogether and destroy all competition in the process. And that becomes very problematic for us from a consumer welfare kind of point of view. Okay, that does me for covering the cost curves. Again, this is one of two of the follow-up videos from the first set of videos of firms and their customers. This one focused on the cost curve side of things. The other one, if you haven't already checked it out, please do. It focuses on the total revenue of the firm size, the revenue side of the firm, and that is primarily by taking a look at the feasibility set, primarily taking a look at the demand curve and figuring out the revenue sides. That video also, the intent is that that video is the third one in this series because at the end of that video, it does bring together that feasibility set with these cost curves to evaluate that profit maximizing price and quantity through another form. So please take a look at that one if you have not already. Till next time.